Welcome to another episode of libGDX-Graph devlog. In this episode, I'll show you how to read scene depth in the shader, and also how you can use this, for example, to create a force field effect. So I have here an example of a scene where we have this wall which is a force field, and an object that passes through it. So this is for at the moment set up with this pipeline, very simple pipeline. We have a default shader, which is responsible for drawing normal objects, like in this case, the sphere, and it just outputs the white color. And we have the force field shader, which is at the moment just outputting a blue color with an alpha of 0.2. So what's important here is that these two shaders are in separate render passes. So here how we create a new one. You just can create a new shader here. I can remove the pass entirely. The importance of this being in a separate render pass is that depth is being set up after each render pass. So if they were in the same render pass, the whatever is being drawn in the default shader would not be available to be read as a depth in the force field, even though force field as a transparent shader is going to be rendered after everything that is being drawn as an opaque. Therefore, they have to be in separate render passes, and the information from this render pass, the first one, is going to be available as to be read in the force field. So the force field, the second render pass in the force field shader. So how we're going to do this is, in the provided part, we have scene depth, and we have to provide screen position. This is something that you can, so this is by default, the screen position is a position on the screen of the currently drawn pixel, and the scene depth you can read from anywhere on the screen you want. In this case, I want to read in the same place where it is. Okay, and scene depth is basically the distance of the currently what is being rendered from the camera. So let's show it at the moment. So if we reload, it's going to be white because everything is at least white, at least one distance from the camera, 1 unit. That's why it's being rendered this way. So let's now, what we want to do is something that's going to be happening a lot with the paired with the scene depth. We want to have a distance from camera. So for this, we have camera position, and we have, so this is distance from the pixel that we are being rendering now. This is scene depth, scene distance of the scene from camera. So we here will have position. We want to subtract one from the other. Calculate distance one from the other. So in here we have distance of the rendered pixel at the moment in this shader from the camera, and we want to subtract these two. So if you subtract the depth from the distance and use this as an alpha and save, reload, we are slowly seeing, but we're just seeing the opposite. So what I want to do is actually the opposite. So what I'll do here is I'll do math subtract constant value of 1. So 1 minus this distance from the point. So I'm taking here 1. Let me move this a bit to the left. So we have a distance of, so let's group this. This is pixel distance from scene. So currently drawn pixel distance from scene, and we are doing 1 minus this distance and using this as an alpha. So let's test this. So that's better, what we are seeing, except in here, because the distance is above 1, then 1 minus above 1 is going to be 0. That's why we have alpha of 0 in here. So what we can do in here, we can add another node here, maximum, and we're going to say is that it has to be at the least 0.2. That's how the maximum value works. Okay. So now, okay, we are seeing better. Now, how do we, so at the moment, the size of this information here is based on it's basically one depth. So whenever the distance from the point that we are rendering at the moment to the depth of the scene is 1, then it falls off. But we want to be able to have control over it. So what we do here is we multiply this distance, or divide this distance from scene by, let's say, constant 0.5. So if we divide it and use this into a subtract, we should be having much smaller band. Yeah, so this basically defines how big the band is going to be. So if you go 0.1 here, the proximity detection is much smaller, as you can see here. 0.1 is probably not very good. If you do go above 1, let's say 1.5, the proximity triggering of the force field is going to be much larger. Let's reload. Yeah. So that's how you can use scene depth. You can read the scene depth and how you can use it to create this force field effect. Of course, at the moment I'm using just a color here. You can provide any kind of pattern you want into here. If this pattern has some kind of alpha, you can multiply it by the result of this alpha and provide this as an alpha here. So you can modify the, let's say, color here. Let's go some kind of pinkish. I save it here, reload, and now we have a pinkish force field. So that's how you can read scene depth. The important part to remember is that the depth that is available in the pass is all the objects that are being rendered in previous passes. So you need to separate them in separate render passes. Okay, I hope you find this useful. Please consider subscribing and liking the video. Thanks for watching. Bye.